Okay. We're on page 11 of your polynomial notes, and we're looking at the rational zeros theorem. Suppose all the coefficients in a polynomial f of x are integers. Don't let that big equation fool you or scare you. It's no biggie, okay? All right, if x equals p over q is a rational zero, where p and q have no common factors other than 1, then p is a factor of the constant term, and that's at the very end of that long string of numbers where it says a sub naught. Are you seeing that? Mm-hmm. On the very end, your constant's the very last number if you put it in order. Mm-hmm. Mm-hmm. Okay? And q is the factor of the leading coefficient. And for us, that would be like our a. All right? And here they call it a sub n. Because n would be whatever degree you're looking at. Okay? And what we're going to do is just jump straight to an example here. And it says list all the possible rational zeros of this function, f of x. So let's write down the function. F of x equals 10x cubed minus 3x squared plus x, and then minus 6. So what we first need to know how to do is how to find p and how to find q. So q is a factor of the leading coefficient. So first of all, what is q? What is my leading coefficient?
That would be
10x
10.
cubed. Or
it would be a 10, right? Yeah. So what I'm going to do is I'm going to write 10 out kind of to the side of q here, and I need to know all the factors of 10.
1 and 10, 2
okay.
and 5.
Perfect. That's pretty much going to do it, right? Yeah. But I'm going to write them as plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Okay? Mm-hmm. Because I could have a negative or a positive, right?
Yeah.
So I need to take all that into account. Now, where's my constant?
Negative 6.
Negative 6. So I'm going to put negative 6 out here. Okay? What are my factors of 6?
Well, it'd be
1 and 6 and 2
1,
and 3.
Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6.
Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, if you read up top again, it says if x is a rational zero, x equals what? P over q. Oh, my heavens. So I have to look at all the combinations of p's divided by q's. Mm-hmm. And that's what we're going to do. But if this has a rational zero, which means, okay, you know how when you draw a polynomial, this is third degree, right? Mm-hmm. So it would start low, high, low, high, right? It could cross the x-axis 3 times. Mm-hmm. It could cross it just once. Mm-hmm. It's either going to cross it once or 3 times.
Yes.
Okay? It has to be one of those. Now, if it crosses, that's automatically a real zero. If it crosses, it's real. What we don't know is if whether or not it has a square root involved. If there's a square root in the answer, it's an irrational, even though it's still real. If I can write it as a fraction, it's rational. What this rational zero theorem says, if there is a rational zero, if a zero can be written as a fraction, mm-hmm. then it's going to be one of these combinations or it's not going to exist.
Okay.
It has to be one of these combos or it's not going to be there.
Okay.
Okay, so what I'm going to do is I'm going to erase my 2 little things here, and then I'm going to show you how to write it all out.
Okay.
Okay? So let's get rid of that and that. And I'm going to just rewrite the function over here so we can see what we were looking at. 10x cubed minus 3x squared plus x minus 6. So I can erase that as well. And I'm just going to put p over q here so I get my p's and q's all straightened out. Whenever I'm doing one of these, the first thing I want to do is I want to locate my q and my p, mm-hmm. and I want to put them down here, and then I want to write all the factors with the plus or minus. That's the first thing you do. The second thing you do is you come up with all your combinations. Okay? So, let's see. My q list here, first I'm going to start with this. Okay, I'm going to have 1 being my denominator. So if 1 is my denominator, it can look like this. 1 over 1, and I'm just going to put plus or minus up here at the top. Okay?
Okay.
And then I'm going to have plus or minus 2 over 1,
Okay.
and then plus or minus 3 over 1.
Mhm.
What would my next one be?
Plus or minus 6 over 1.
Yep. Okay, I'm going to quit putting commas in between each one and just do commas in between the sections.
Okay.
All right, so I took care of this one. What's my next denominator possible? 2? So, denominator 2. What's my possible numerators?
1.
So I'm going to put plus or minus 1. And another 2 on the bottom. What could it be?
Plus or minus 3.
Well, no, we're going to not skip it. The reason we're not skipping is we're going to cancel out later.
Oh, okay.
Okay, we're going to write down every possible, and then we're going to see where we actually, because you can see plus or minus 2 over 2 is the same thing as plus or minus 1, but we're going to simplify later. We're just going to write down all our possibilities first and then simplify later. Deal?
Yep.
So, let's see, what's our next one? Plus or minus 3 over what?
2.
2.
Okay, and our last one?
Plus or minus 6 over 2.
Okay. All right, now what's our next denominator we can look at? 5, right? So this is going to be over 5. What are my possibilities for over 5? Plus or minus 1, plus or minus 2, plus or minus 3 over 5, and plus or minus 6 over 5. Doing good so far? And the last one, 10 could be my possible denominator. So plus or minus 1 over 10, plus or minus 2 over 10, plus or minus 3 over 10, or plus or minus 6 over 10. Does that look right?
Yeah.
So